Friends, in today's lecture we are going to learn how to write programming of 8085. As we earlier studied the instruction set of 8085, in which we studied data transfer group instruction, arithmetic group instruction, logical group instruction, then memory management instruction and so on. Now how to implement that instruction actually and how to write the program, that we are going to see with some examples. Today's example is write an ALP. ALP means arithmetic logical program, to add two 8-bit numbers. One is stored at 5050 hex and other is stored at register B, and then after addition results will be stored in 5051 hex and in register C. So whenever such ALP is asked to solve you, there is question number 5 in the theory exam, which contains 10 marks. Require 2 programs to write out of 3, and question 5 is OR for that same. So in all there are 6 programs. Out of that we have to write only 2 programs. While writing these programs, we have to take precaution that first we have to think about the algorithm, then flowchart, and then start to write coding. Don't directly start the coding. Actually coding carries the mark only. Algorithm and flowchart doesn't carry any mark. But why algorithm and flowchart is required? It gives us proper guidance to write the code. So thinking of this problem, the algorithm for this problem is that first step, of course, start. Second, initialize memory to 5050 hex, as one of the operand is at 5050 hex. Then this operand is moved to the accumulator, because we know that to perform any arithmetic instruction, one of the operand should be in accumulator. And second operand is in register B, which can be directly add. So next step is add that data in register B with accumulator. Now we have to store this answer in memory location as well as in register. So first we are storing it in memory by incrementing the memory. So next step is increment memory by 1, then move data in accumulator to that memory, which is opposite to that 3. We are now in step number 3 we are moving memory to accumulator. Now here we are moving data from accumulator to memory, which is our result. And next move data in accumulator to register C, and then we have to stop. Okay, so here in practical we have to write restart rather than start. So depend upon this algorithm we are drawing flowchart. You all people know what are the flow diagrams that we are using for start, stop, then for input, output, processing. Okay, according to that you have to draw the flowchart. As this is the first program, for 1 or 2 more program I am giving this algorithm and flowchart, and after that you have to draw yourself. Okay, now coming towards coding. See, either it is in practical or it is in theory exam, you have to draw a table like this. The first column which gives us memory of the program, second used for label, third used for mnemonics, that is actual instruction which we are writing, then opcode, which is operational hexadecimal code used by that machine, and last one description or comment we can say. So we have to select memory to store the program other than where the data is stored. So here in our program data is stored at 5050 hex. So avoid that memory and start memory from 2000 hex. So starting this memory from 2000, you can take any memory, not compulsory you have to take 2000 hex. 2000 hex, label start, first instruction as we seen in algorithm, initialize memory, and for that we are using LXIH, that is load HL pair with 5050 hex. So it is 3-byte instruction. It takes 2000 hex, 2001 hex and 2002 hex memory to store this instruction. The first is opcode 21 hex, second is operand lower bit data, and third one is operand higher bit data. So 5050, because here both lower and upper bit are bytes that nibbles are same. Now next is comment or description. So it should always start with semicolon, and you have to write description of that instruction. What LXI is doing, it initializes the memory where 5050 hex. Now the next instruction, which is at location 2003 hex, because 2000, 2001, 2002 are used by LXI. Next instruction is move from where, from this memory 5050 hex to accumulator. So move A comma M. This instruction is 1-byte instruction. It takes only one memory. It moves data from memory to accumulator. So next instruction is to add add from where? From B. So at B, 1 byte instruction again, so it takes only one memory location. It will add data in register B to data in accumulator. Now we have to store the result in accumulator at memory as well as in register C. So first we are storing it in memory. For that purpose we have to increment the memory, because they asked to store us in 5051X. So by incrementing we get 5051X. So INXH, next instruction is INXH. Then its description is increment memory by 1, and after that we are moving that data from accumulator to memory, move M comma A. Okay, so after moving that data in memory, we are moving same data, because accumulator content does not get vanished after moving. So we are moving this accumulator content again to register C by using move C comma A. All these are 1 byte instruction taking 111 memory location. So at last we are writing restart. RST1 means restart the processor to take input and give output. So write this program in your notebook. Tomorrow we will see the program of subtraction. Thank you.